Scientists of Reddit, what are some crazy theories that could be true? Story 1. In the early 1900s, the chestnut blight was introduced to the United States, and ever since, American chestnut trees across most of the country have been unable to fully mature, dying at nearly the same stage of growth. In college, much of my research focused on this problem. My master's thesis proposed that the chestnut gall wasp plays a direct role in the tree's developmental issues by altering hormonal balances within the C4 photosynthesis pathway. Those hormonal disruptions appear to interfere with the key protein coupling mechanism, which in turn worsens the effects of the blight. My doctoral research is now confirming this link and exploring ways to limit gall wasp populations, which could eventually allow chestnut trees to regrow naturally. If successful, they could once again dominate the American landscape as they did centuries ago. I even have a personal specimen in the Smithsonian credited to my professor and me, marking the first documented gall wasp this far north on the East Coast. Story 2. Paleontology, Darwin's dilemma refers to the puzzling absence of large, complex fossils from before the Cambrian period, around 541 million years ago, when Darwin first proposed his theory of evolution. He expected that older fossils, once discovered, would reveal the ancestors of modern animals, and they were eventually found the Ediacaran biota, discovered in the Ediacara Hills of South Australia. Early researchers excitedly classified them as primitive jellyfish, worms, and other early versions of life we know today, but that turned out to be completely wrong. Consensus is now shifting toward the idea that most Ediacaran organisms weren't related to anything alive today. They represented entirely extinct lineages living in a world with environmental and biological conditions unlike anything we've seen since. For decades, we tried to fit them into our familiar evolutionary narrative, and in doing so, we overlooked what might be one of the most alien ecosystems in Earth's history. Understanding it could reshape how we think about the origins of complex life, both here and on other planets. Story 3. Chemistry. Eventually, we'll be able to design enzymes from scratch to perform incredibly complex chemical reactions that would otherwise be impossible with traditional methods. Back in 2008, a team led by David Baker, Ken Houck, and Forrest Michael published a groundbreaking paper in Science showing this idea in action. They digitally designed an enzyme, a Diels aldehyde, that could catalyze a specific Diels-Alder reaction. They modeled the transition state, designed the active site, built the protein, and it worked exactly as intended. Since then, their work and others like Scott Miller's group at Yale have pushed the boundaries even further. Miller's team has designed small peptide catalysts that can make precise, site-specific chemical modifications on massive molecules like vancomycin, one of our most powerful antibiotics. This field is slowly blurring the line between biology and chemistry, turning enzymes into programmable molecular tools. Story 4. Psychology, psychiatry. There's an ongoing debate in neuroscience and psychiatry about what actually causes depression on a biological level. Traditionally, it's been linked to neurotransmitters like dopamine and serotonin, largely because antidepressants that affect these systems tend to help over time. But even after decades of research, we still don't fully understand why they work or why they take weeks to show results. A German psychiatrist recently proposed a very different theory, that depression could stem from a chronic overdose of cortisol, the body's main stress hormone. He even treated patients using a cortisol antagonist, and some reportedly showed dramatic improvement within hours. His model hasn't gained widespread acceptance yet, but if it holds up, it could completely change how we view and treat depression. Story 5. Classics archaeology. This one sits somewhere between archaeology and ancient history. Studies of oral cultures like certain groups in the Balkans show that societies without writing systems often develop incredible memory retention. That's how epic poems like the Iliad and the Odyssey could survive centuries through oral tradition before being written down, relatively unchanged. Some scholars believe that these oral accounts even preserve astronomical observations that can be used to date real events like the fall of Troy. When those celestial descriptions are analyzed, the dates they suggest align surprisingly well with the archaeological evidence for the destruction of Troy. Sebep of the city, most historians now agree, was Homeric Troy. So in a strange way, poetry and starlight may have carried the true date of Troy's fall across thousands of years. Story 6. Neuroscience. In neuroscience, paraplegia and quadriplegia are no longer unsolvable mysteries. They're engineering challenges we're actively overcoming. We've already reached the point where brain signals, captured through EEG or other non-invasive methods, can be translated in real time to control simple machines like a robotic arm or a computer cursor. The next frontier is scale, enabling those same patterns to control entire limbs fluidly and naturally. Miguel Nicolelis, one of the leading researchers in this field, is already working toward that goal. His team has been developing a brain-controlled exoskeleton designed to let a paralyzed person kick a soccer ball, a demonstration planned for the World Cup. It sounds like science fiction, but it's happening now. And this is just the start. The broader field of brain-machine interfaces is exploding, driven by the idea that we can decode the brain's activity patterns to control machines even if we don't yet fully understand why those thoughts exist in the first place. It's less about reading minds and more about recognizing consistent patterns and translating them into motion. It's a fascinating illusion of thought control, and it's rapidly becoming reality. Story 7. Cancer biology. In the not-so-distant future, traditional chemotherapy will rarely be a first-line treatment for cancer. We're already seeing this shift. For certain cancers, especially blood cancers, targeted therapies are replacing broad-spectrum chemo. Small molecule inhibitors and monoclonal antibodies are showing remarkable success in late-stage clinical trials, often with far fewer side effects. And beyond that, cell-based therapies like CAR T-cells are proving just how powerful personalized treatment can be. These approaches don't just attack cancer, they teach the body to fight it more effectively. As treatments become more precise, safe, and specific, the era of chemotherapy as the default option is ending. It's an incredible thing to witness the idea that one day soon, I'll be able to hand a patient a simple pill with minimal side effects instead of the brutal regimens we've relied on for decades. Story 8. Astronomy. There's a phenomenon in radio astronomy known as Lorimer, bursts mysterious flashes of radio energy that last only a few milliseconds, yet release as much power as hundreds of millions of suns. The first was detected only recently, and since then, just a handful more have ever been seen. What makes them so baffling is that they seem to come from billions of light years away. In other words, something unimaginably powerful is sending out these signals, and we have no idea what. For a while, some thought they might be weather interference, but the bursts have now been verified enough that most scientists agree they're real. We just don't know what's causing them. Curiously, almost all detections so far have been made at Australia's Parkes Observatory. Yes, the same one from the movie The Dish. Astronomers everywhere are hoping to be the first to spot one somewhere else to confirm they're not a local anomaly. Personally, I like to believe they're real, distant, and utterly alien the universe, throwing us a curveball we barely have the tools to understand. And who knows, maybe someday I'll catch one myself. It'd make a great chapter in my thesis. Story 9. Cetology. There's growing evidence that baleen whales like humpbacks might be capable of a primitive form of echolocation. This idea comes from recordings made during several whale rescue operations, where stranded humpbacks trapped in rivers produced a series of strange, high-frequency whistles unlike anything heard before. Some researchers think these sounds may help the whales map their surroundings when disoriented in shallow or murky water. At the same time, scientists suspect that dolphins, especially bottlenose dolphins, may navigate by sensing the Earth's magnetic field. This could explain why mass beachings sometimes occur in areas where magnetic lines converge or distort. There is some observational evidence supporting both theories, though no clear biological mechanism has been identified yet. It's hard to isolate after all. It might take only a handful of specialized nerve cells to do it, and dolphins have over 1 billion in their bodies. Still, it's an intriguing mystery. These ocean giants might be using tools of perception we can barely imagine. Story 10. Psychiatry. Recent research has revealed something remarkable. 5 major psychiatric disorders, including depression, bipolar disorder, schizophrenia, ADHD, and autism, share common genetic mutations affecting the brain's voltage-gated calcium channels. These channels are crucial for neurotransmitter release, how neurons talk to each other. This might explain why drugs that increase neurotransmitter levels, like SSRIs, can sometimes relieve symptoms across seemingly different conditions. It could also shed light on why electroconvulsive therapy still works for some treatment-resistant depression cases. The electrical current might temporarily reset or activate those same calcium channels that are disrupted by genetic mutation. Psychiatry remains one of the least understood areas of medicine. We still don't fully know why mental disorders happen, but little by little, we're uncovering the threads that connect them all. Story 11. Biology. Once personal genomic sequencing becomes as routine as an annual physical, medicine will enter a new era. Imagine every person's DNA stored in an anonymized, protected database. With enough data, researchers could statistically map nearly every disease, trait, and predisposition back to its genetic roots. Right now, we're limited by what some call combinatoric black holes regions of the genome, where our sample sizes are too small to reveal meaningful patterns. But that's changing fast. Companies like 23andMe have already shown what's possible on a smaller scale, linking genetic variations to ancestry, metabolism, and even disease risk. As costs drop and access widens, personal genomics could become a universal medical baseline, available regardless of income or geography. Once that happens, we won't just treat disease, predict it. Story 12. Chemistry. Many of the reaction mechanisms we take for granted in chemistry might not be quite right. Take the classic reaction between alkali metals and water, that violent, explosive burst we've all seen in demonstrations. The accepted explanation is simple. The metal dissolves, loses an electron to hydrogen ions, forms hydrogen gas, and the heat from that reaction ignites it. But recent experiments suggest something more complex and more beautiful is happening. Scientists have observed flashes of color in the vapor above the reaction, indicating that the metal might actually vaporize at the interface, reacting in the gas phase rather than through simple dissolution. In other words, the explosion might not start in the water, it might start above it. Even in one of chemistry's oldest textbook reactions, there's still mystery in the details. Story 13. Cancer biology. We're on the edge of a revolution in how we treat cancer, one driven by your individual genome. Soon, sequencing a tumor will be as common as ordering blood work. Doctors will know exactly which mutations are driving a specific patient's cancer, and more importantly, which drugs can target them. We already have the first examples of this personalized medicine. The drug erlotinib, for instance, works specifically in patients whose cancers carry mutations in the EGFR gene and barely affects those who don't. In the next decade, oncologists will have an entire toolkit of such drugs. Each patient's treatment will be customized, a precise combination of therapies designed for their genetic fingerprint, minimizing side effects and maximizing survival. It's not science fiction anymore. It's medicine, catching up to the complexity of biology. Story 14. Ecology. Biology. Culture isn't uniquely human, even whales have it. Among orca pods, scientists have observed distinct hunting traditions that pass from generation to generation. Some pods coordinate to create waves that wash seals off ice floes. Others beach themselves deliberately to snatch prey near the shore. These techniques differ dramatically between regions, suggesting their learned behaviors, not hardwired instincts. And when one orca invents a new strategy, others watch. If it works, it spreads taught from mothers to calves, refined across decades. That's culture in its purest form. Knowledge shared, tested, and preserved. Proof that evolution doesn't just happen through genes, it happens through learning too. Story 15. Physics. Remember the cold fusion controversy from the late 1980s? The idea that nuclear fusion, the same reaction powering the sun, could occur at room temperature. It was quickly dismissed, and the scientists behind it, Pons and Fleischmann, saw their reputations destroyed. But decades later, evidence is quietly resurfacing that they might have stumbled onto something real. The field now goes by a new name, low-energy nuclear reactions, LANR. And the emerging theory isn't traditional fusion at all. It suggests that protons might be capturing electrons to form low-energy neutrons, which are then absorbed by nearby nuclei. Those unstable isotopes break down, releasing measurable heat. It's still controversial, the field is crowded with wild claims and unverified experiments, but physics isn't as impossible as it once seemed. If LANR turns out to be real, it could rewrite our understanding of nuclear energy entirely. Story 16. Botany epigenetics. Back in the 1970s, a few obscure experiments hinted at something strange, that plants could remember the hardships of their ancestors. Researchers found that violently shaking certain trees or growing them in high winds would cause their offspring to grow stunted for several generations. Then, as if a switch flipped, their great-grandchildren would return to normal size. At the time, it didn't fit into Darwinian evolution. There was no known mechanism to explain how environmental stress could affect future generations without changing DNA itself. Then came the discovery of epigenetics, the realization that chemical markers can switch genes on or off, and that some of those changes can be passed down. We still haven't drawn a direct line between those early plant experiments and modern epigenetic theory, but it's likely they were seeing this process in action evolution, not through mutation, but through memory. Story 17. Evolution genetics. In industrialized societies, people are having children later and later, often well into their 30s. It seems harmless, even wise, but biologically, there's a hidden cost. Every time a sperm cell divides, there's a small chance for mutation. Since male germ cells divide continuously throughout life, by age 30 or 40, they've undergone hundreds of more divisions than they would have in early adulthood. Across mammals, this leads to a roughly 5-fold higher mutation rate in males. That's especially concerning for the Y chromosome, which doesn't recombine during reproduction, meaning any mutation that occurs there stays. Over many generations, this could contribute to a gradual accumulation of harmful changes in the human genome. It's not a doomsday scenario, but it's a quiet reminder that even social progress has biological trade-offs, and evolution never truly stops. Story 18. Meteorology technology. The future of weather forecasting isn't in satellites, it's in your phone. Meteorologists predict that within the next 2 decades, billions of everyday devices, cars, phones, even smartwatches will contain microchips constantly recording local weather data, temperature, pressure, humidity, wind speed. Each chip becomes a sensor. Together, they'll generate millions of data points every second, feeding supercomputers capable of real-time atmospheric modeling. The result? Hyper-local forecasts are so precise they'll predict rainfall on your street corner, accurate down to the minute. The technology already exists. All that's left is the computing power to process the storm of information. Story 19. Fluvial geomorphology. For decades, geologists believe river systems work like well-tuned machines, adjusting their flow and shape to maintain dynamic equilibrium as the landscape slowly rose and eroded. But that idea is being challenged. Jonathan Phillips, a geomorphologist from the University of Kentucky, argues that rivers don't operate in balance at all. They behave more like chaotic systems, driven by feedback loops and random disturbances. His view sees rivers as non-linear, ever-shifting entities carving, flooding, and reshaping themselves unpredictably over time. Now, with advances in computational modeling, we can finally test these ideas. Global simulations of sediment transport are already running on modern computers, revealing that chaos, not stability, might be the true language of Earth's surface. It's a shift in perspective from harmony to turbulence. Story 20. Psychology, biology. This one's controversial, but worth considering. Hormonal birth control might subtly influence attraction and even marriage stability. In one famous experiment, women were asked to smell t-shirts worn by men. They preferred the scent of men whose immune systems were genetically dissimilar to their own, a subconscious cue that promotes healthier offspring. But women on hormonal birth control showed the opposite preference. They were drawn to men whose immune systems were similar, almost as if their body chemistry mistook those men for family. Now imagine this on a population scale. Millions of women meeting partners while on birth control, then later going off it to have children. Their hormonal balance and even perception of attraction can change. Some researchers believe this might subtly contribute to relationship strain or divorce, and that children from such pairings could have less genetic immune diversity. It's not proven, but it's a fascinating reminder that our hormones may shape far more than just our biology. They may quietly guide who we love and why. Story 22. Prion biology. There's a silent threat lurking in North America's forests, chronic wasting disease, CWD. It's a prion disease that infects deer, elk, and moose, slowly destroying their brains in a way eerily similar to mad cow disease, BSE. So far, CWD hasn't been proven to infect humans, but many scientists believe it's only a matter of time. Prion diseases are infamous for jumping species barriers, and when they do, the consequences are devastating. Because prion infections can take years to cause symptoms, it's possible that patient 0 has already eaten contaminated venison, and no one would know until it's far too late. If CWD ever adapts to infect cattle, and then humans, it could make the BSE outbreak of the 1990s look small by comparison. Most people aren't paying attention anymore, but prion biology rarely gives warnings twice. Story 23. Psychiatry neuroscience. It's becoming increasingly clear that many psychiatric and neurological disorders, depression, bipolar disorder, epilepsy, and schizophrenia, may not be as distinct as we once thought. Traditionally, medicine has treated these conditions as separate entities, each with its own cause and cure. But emerging research is finding deep biological overlap, shared genetic factors, similar brain activity patterns, and even common responses to medication. For example, certain antipsychotic drugs like aripiprazole, Abilify, are now approved to treat forms of resistant depression. Meanwhile, conditions like psychogenic non-epileptic seizures blur the boundary between neurological and psychiatric illness entirely. All of this points toward a unified model of brain disorders, one that treats them not as isolated labels, but as variations of a broader, interconnected system. We're only beginning to see the outline of that model. Story 24. Neurosurgery consciousness. In severe epilepsy, sometimes the only option is drastic. Surgeons disconnect one half of the brain from the other, a hemispherectomy. After the operation, the isolated hemisphere receives no sensory input, sends no output, and communicates with nothing. Yet it remains alive, active, firing, and metabolically awake. Patients lose the memories and personality traits stored in that half forever, but that silent hemisphere keeps running, its neurons still sparking in the dark. What is that half doing? Does it drift aimlessly in meaningless electrical storms, replay old memories it can no longer share, or simply fade into neural noise, unaware that the lights have gone out? It's one of the most haunting questions in neuroscience, a living brain, awake but alone. Story 25. Astrobiology. In 2004, scientists made a discovery that electrified the search for life beyond Earth: methane in the atmosphere of Mars. Both Earth-based telescopes and the Mars Express orbiter detected it. That's a big deal because methane shouldn't last long on Mars. Solar radiation and cosmic rays would destroy it within a few years. So, if methane is still there, something must be replenishing it. The obvious possibilities are geological reactions between rocks and water deep underground, but there's another, far more intriguing explanation: microbial life. If even a fraction of that methane is biological, it would mean Mars isn't a dead planet at all, just a quiet one, still breathing beneath the dust. Story 26. Evolutionary biology, population, genetics. For decades, population genetics has treated genetic drift, the random fluctuation of alleles in a population, as the main force behind most evolutionary change. According to the neutral theory, most mutations are neither beneficial nor harmful, just passengers on the tides of chance. But what if that entire idea has been overstated? In reality, nature may not be quite so random. Even subtle differences in survival or reproduction can ripple through populations faster and stronger than models predict. Selection, not drift, might still be the quiet architect shaping life's diversity. The problem is that neutral drift is easy to model, while real-world selection is messy, dynamic, and full of feedback loops. We've simplified evolution into coin flips when it's really a complex system of interacting advantages and environments. Perhaps the neutral theory was never wrong, just incomplete. Story 27. Environmental biology, ecology. There's a growing invisible pollutant in our water, and it's not plastic or oil. It's hormones. Every day, millions of people take medications, birth control pills, antidepressants, painkillers, and trace amounts of these drugs pass through the body and into the sewage system. Wastewater treatment plants can filter out solids, bacteria, even chemicals, but not molecules designed to mimic the body's own biology. In rivers across the world, scientists are finding fish with both male and female reproductive organs, warped hormone levels, and collapsing fertility. In England and the Pacific Northwest, trout and salmon populations are already showing these symptoms. The culprit? Synthetic estrogens and progesterones, microscopic in dose, but enormous in consequence. If these compounds continue to accumulate, they could reshape aquatic ecosystems from the bottom up and eventually, through the food chain, find their way back into us. Story 28. Computer science, machine learning. Within a decade, artificial intelligence may quietly outthink us, not in games or art, but in decision-making itself. Already, algorithms can predict consumer behavior, health risks, and election outcomes with uncanny accuracy. One famous example, Target's data system once detected that a teenage girl was pregnant before her own father did, based solely on her purchasing patterns. Now imagine scaling that capability up. Machines could soon optimize policies, investments, and entire economies better than humans ever could. When the data says one strategy is mathematically superior, what room remains for debate or democracy? At some point, we may have to confront an uncomfortable truth. When machines make better decisions than people, what becomes of leadership itself? Story 29. Neuroscience Microbiology. Inside your gut lives a vast hidden ecosystem, trillions of bacteria communicating in a language we're only beginning to understand. For decades, we thought these microbes just helped digest food, but now we know they do much more, even influencing your mood, your stress levels, and your mental health. Some gut bacteria produce the same neurotransmitters your brain uses: serotonin, dopamine, GABA, and somehow, through neural and chemical signaling, your gut and brain talk to each other. Scientists are calling it the gut-brain axis, and it's reshaping how we understand anxiety and depression. If this link proves true, the next antidepressant might not be a pill for your brain, but a probiotic for your stomach. Story 30. Medical Science Neurology. In the race to decode disease, we may have been looking in the wrong place all along. For years, medical research has focused almost obsessively on genetics, the search for faulty DNA that explains everything from cancer to Alzheimer's. But what if genes are only part of the story? Take ALS or Lou Gehrig's disease. Only about 10 of patients have a hereditary link. The other 90, their condition appears spontaneous, triggered by something in their environment, not their DNA. The truth may be that many chronic and neurodegenerative diseases arise not from mutations, but from a complex interplay of toxins, infections, stress, and nutrition factors we've ignored in our genomic gold rush. The next medical revolution might not come from sequencing our genes, but from decoding the world around us. Story 31. Classical history literature. Even the ancient world had its mysteries, and not all of them were carved in stone. Take Ovid. After writing his masterpiece, Metamorphoses, he was abruptly exiled from Rome to a remote town near the Black Sea. The official reason? Carmen et error, a poem and a mistake. But what poem? What mistake? He never said. Instead, he spent his exile writing verses of grief, lament, and self-pity. For centuries, historians believed Ovid's punishment was real, a tragic end for one of Rome's greatest poets. But some scholars now think the whole thing might have been fiction, a satirical performance staged in Rome itself. The banishment may have been part of an elaborate joke, Ovid playing the role of the outcast poet while his audience laughed along. Then there's Catullus. His fiery love poems to Lesbia, likely based on the aristocrat Clodia, shaped the very language of passion in Western literature. But what if Lesbia never existed? Her beauty is never clearly described, her presence felt but never detailed. To some, that means she was never a person at all, but a literary invention a Roman muse conjured purely from verse. Perhaps the greatest poets of Rome weren't just writing about love and loss, they were performing it. Story 32. Biology Toxicology. The modern epidemics of diabetes and vascular disease might not begin in our genes or our diets, but in our water. During graduate research, I studied the effects of low-level arsenic exposure, the kind found in drinking water across much of the world. Even at safe concentrations, it altered the cells lining the livers, tiny blood vessel cells that act like filters, full of microscopic pores. Under arsenic exposure, those pores began to close. The liver could no longer clean blood effectively. Fat accumulated between organs. lipid droplets swelled inside cells. The animals developed the same kind of dangerous abdominal fat seen in human metabolic disease. Across regions with high groundwater arsenic, rates of diabetes rise quietly, consistently. If this link proves real, it means one of the world's most pervasive toxins isn't just poisoning, it's rewiring metabolism itself. Story 33. Biology, Immunology. It turns out our immune systems may be too clean for their own good. For most of human history, our bodies evolved alongside worms, bacteria, and countless microbes. These organisms didn't just coexist with us, they trained our immune systems, teaching them how to tell friend from foe. But in the sanitized modern world, we've driven many of these ancient companions away. The result? A confused immune system that attacks the body it was meant to protect, leading to autoimmune diseases, allergies, and inflammatory disorders. This idea, called the Hygiene hypothesis, is gaining traction, and it's leading to radical new treatments using carefully controlled worms or microbial proteins to re-educate our immune systems. It's a strange thought that the cure for modern illness might lie in reuniting with the microscopic world we've spent a century trying to escape. Story 34. Primatology, Cognitive Science. We've long assumed that what makes humans special is language, the ability to think in words. But what if that's our biggest blind spot? Our understanding of animal intelligence has always been filtered through human perception. If an animal can't speak, we assume it can't think like us. But mounting evidence suggests that many species from apes to elephants to birds display rich, abstract cognition without language at all. And here's a provocative twist. What if language itself evolved from music? Humans are one of the few species that can synchronize movement with sound rhythmically, precisely. Some researchers believe early humans used song-like calls to coordinate and communicate, long before they spoke in sentences. Over time, rhythm became structure, melody became meaning, and music gave birth to language. If that's true, then our minds are not just linguistic, they're musical. And the gap between us and the animal kingdom may be far narrower than we've ever imagined. Story 35. Physics, Cosmology. We assume matter and antimatter behave as mirror images, identical in every way except charge. But what if even gravity doesn't treat them the same? In theory, antimatter should fall just like ordinary matter, yet no one has ever truly tested it. Creating, cooling, and trapping enough antimatter to observe such a subtle force has always been nearly impossible. But if it turns out antimatter repels matter instead of attracting it, the implications would rewrite cosmology itself. It could explain why our universe seems dominated by matter. The antimatter might simply have been pushed away, forming its own vast invisible half of the cosmos. Two universes separated not by space or time, but by gravity's sign. It sounds like science fiction, but physicists are getting closer to finding out.